We will be today discussing IoT core, data analytics, and of course cloud. So, we will be using the Google platform for this. So I will try to club two things: the theoretical aspect, which you must have already understood from the previous lectures, but I will still have a brush up with these ideas. The second thing is I will try to have a hands-on, the pure IoT thing, kind of a thing. Introduce you to the kind of a actual live environment where you will be able at least to understand how this IoT core cloud data analytics kind of a thing works. So has any one of you worked on IoT analytics, or just has anybody worked on IoT, hands-on IoT? Any kind of previous experience where you have worked on IoT?
Please, among the participants, you can unmute your mic or you can share
This is going to be a very interactive session, so
Yes,
I will request the participants to speak up.
So we have created projects like home automation projects or parking system in this domain.
Okay. So anyways, assuming that some of you must have worked on it, and I will straight away go to the technical aspect of this topic. We are trying to club three topics here. The first topic which we are actually going to discuss is we're going to discuss IoT. The second thing is data analytics, and the third one is cloud. So Google offers us all of the three integrated kind of an environment. So I'm going to log in to my Google Console account. I'm going to have a live hands-on session of IoT, artificial intelligence, and of course cloud. So I will be first sharing the screen. Bear with me for a moment. Is screen visible?
Yes, sir. It's visible now.
Yes, it is visible, sir.
Okay. I think the presentation is also visible, huh?
Yes.
Okay.
Yes.
So I'm not going to start with the presentation. I'm going to first start with the technical aspect. So I will be hopping between the two things, and please interact with me wherever you tend to have any such issues where it becomes kind of a difficult. I'm not sure if any one of you have actually had a hands-on experience of IoT and data analytics. So it's kind of an introductory aspect, not a full blown, but still it will be kind of where you will get a 360-degree perspective of how these things work together. So to start with, I'm going to the real life environment, and for that I will log on to my Google Cloud account, console.cloud.google.com. I hope this is visible. So first, guys, you have to, I will be also sharing some kind of information in the chat. You are supposed to, all of you, console.cloud.google.com. This is an environment, integrated environment offered to you by Google, almost for every technical aspect, which includes the data analytics and IoT, among other things. So we will just have a preview of what all the Google offers us. Interestingly, if you are a newbie and you're doing it for the first time, the Google offers you around 20,000 plus of resources free of cost, and you can start working on this integrated environment. But of course, you have to open an account, the credit card details. They don't charge you. They charge you only 2 rupees initially so that you get hands on it. But once you do get into the serious business where you are using the resources, and then yes, it matters how much of resources you use. So anyways, this is the platform which is visible on your screen. On the left side, we have a navigation menu. So if we traverse down, we will come into many things, including the database, file stores, big data, API gateways. Then if we go further down, there is PubSub and IoT Core, which will be of your interest in this FTP. One is IoT Core, the second one is PubSub, and the third one is your AI platform. So just a overview. So this is how we start with and how we work with it. So the first thing you need to go through is this IoT Core. So this allows you to work on IoT devices across the globe, and you can control them, use their data, integrate them, clean them, analyze them here on the Google platform. So before we have a practical aspect of how this happens and what all hypothetically and virtual devices we require and what all physical devices we require, we will first go to the just try to understand the different terminologies which we come across. So we start with the presentation, keeping in mind, one, there's an IoT core. So the term here is IoT core, not IoT. The second one is AI, Vertex AI or AI platform. So in this, we have a model training and prediction system. I hope this part of the screen is visible with you guys. This model training. So we are going to integrate IoT with machine learning here and from the data analytics point of view. The third thing which you will be requiring if you're working on IoT here is PubSub. This is the third one, the PubSub. Publications and subscriptions. So we'll try to get some part of it. We have a limited time, but as much as we have, jitna humse ho payega, jitna, as much as it's possible for us to do, we'll try doing. To start with, this is how we start. This topic is basically 3 topics in itself, at least 3 topics. One is IoT. So IoT devices, you know, almost all of us are right now in one way or other way using those devices. The second one is when we have these IoT devices, how do we extract the useful data out of it? Then we perform the analysis. And of course, then once the analytics part is done, we will be in a position to monitor the applications remotely. So from the introduction part of it, which most of you must have already done in these sessions, but from a pure definition point of view, the IoT is an interconnection of several devices, networks, technologies, human resources to achieve goal. There are a variety of IoT-based applications being used in different sectors and have succeeded in providing huge benefits to IoT, to the users. The Internet of Things paradigm is both revolutionary as well as enabler of automated and convenient lifestyle for modern day humans. The Internet of Things applications have grown in massive numbers, generating a large amount of data required for intelligent data processing. But before we, I need to discuss this one page and understand what is this volume of data we talk about Internet of Things. How much is this volume of data? Even if you look at simple examples like smartwatches, uh, ad hoc networks we use for measuring temperatures and other weather conditions, geographical conditions like humidity or wind. How much of data that goes continuously from these devices which are connected with your internet and are stored and analyzed continuously. Now there are two perspectives. If you look at it from an ordinary man's point of view, and you believe that how much does it benefit me? Let's take a data analytics example before we take an IoT example here. The data analytics says is that we need to redefine the kind of prediction we have. Uh, the doctor tells you whether you're diabetic or not. But when you're born, a person is born, we should be in a position to predict whether he will be diabetic or not. So the condition is that the data sciences or data analytics, machine learning is trying to define the orthodox terminologies associated with the basic science. Computer science in itself has outgrown in its basic formation and has gone into different subjects altogether, from medical science to geographical science to academics. Science, from the data science point of view, which many people conceive to be a subject of computer science, is purely mathematics, and it works fundamentally on predictions. We should be in a position to predict whether we are going to have a rain, whether we are going, how vulnerable a person is towards diabetics or heart attacks, what precautions he should change, what lifestyle changes he should make. So let us now club this idea of prediction with the idea of a smartwatch. The smartwatch, which some of us are now using regularly, keeps on tracking your information, keeps on getting what you try to infer is that how much you have walked in a day, the number of calories you have burned. But is it possible, rather it is possible, that the person, say Apple, has around 100,000 users or 1 lakh users or say 10 lakh users or more than that, or Samsung has many such users, and all of these users are, we are gathering the same type of data, and this data is not being collected. So this is where this IoT and data analytics gets interesting. This data is not collected randomly. It is in a continuous process of collection. So every second, actually, you're supposed to transfer the data which you have collected, your pulse, your how much calories have burned. So this information goes two-way process, and it is in a continuous process. It is not something that कि भाई हर 6 घंटे के बाद हमें data देना है. So what happens ideally, the data is being taken continuously from your small smartwatch to a data center where it is stored. So there are two aspects to this. How much of data? Even if this is 1 byte of data that goes per second, imagine the amount of data that is generated by 10 lakh users per second. So you have 10 lakh bytes of data that are generated per second. Can we afford such an infrastructure wherein you can store this data on your local infrastructure? So the first thing that we all encounter is, do we have an infrastructure to store and manage such kind of data? Once we are in this position to extract this kind of data and store it, then we want to analyze this data. So you will find interesting patterns across the globe. Say we will have within India different kinds of data clusters. You will have Punjabis having a specific habits which are restricted to Punjabis. There will be a South Indian habits, there will be a North Indian habits, and then there will be certain habits which will be pan-India, which can be compared then with the habits of United States of America, and you will try to overlap and judge the two heterogeneous converted into a homogeneous data sets. So first, whenever we speak of IoT, we understand the massive amount of data. Once the massive amount of data is generated, we need mechanism to retrieve it, store it, and analyze it. So for that, you will not find much of IoT infrastructure on standalone businesses. You will not find the, say, University of Kashmir has a data center or University of Delhi has a data center. You will not see that IoT centers are managed by standalone companies. Most of the times, they are stored, managed by Google or Amazon, Microsoft, because the amount of space and infrastructure required for it is not possible by a small data center which we have in place. So what we have is that we should have the infrastructural support to extract the data, then store the data, and then analyze the data. The Internet of Things application have grown in numbers. So these numbers are not restricted to smartwatches. You have earthquake predictions. Say, for example, let's take Orissa nowadays, or any other state which is vulnerable to floods. So is it, there are sensors which are continuously monitoring this data. Now this data is being continuously sent and stored and analyzed in order to predict something which is not acceptable to the system. The same goes with earthquakes. In Japan, one of the best IoT devices have been applications have been used for the prediction of earthquake. However, there is a problem. The varying IoT infrastructure, we have a cloud, edge, fog, and the limitations of the IoT application layer protocols in transmitting, receiving messages become a barrier in creating intelligent IoT applications. So this, when we have a varying IoT infrastructure, we fundamentally mean there is a heterogeneity in place. So heterogeneity creates a lot of problems for us. Before I continue with the concept of heterogeneity, I would like to quote Eric Schmidt. He was the CEO of Google, not now, nowadays, long back. In 2011-12, he said the amount of data that is generated, just one second. The amount of data that is generated in 48 hours, I'm talking about 2011-12, the amount of data that is generated in 48 hours is the same amount of data that we had from the day of Adam up to 2003. This is massive amount of data, and this is heterogeneous. This is not in the same infrastructural supported data. You have different operating systems, you have different database systems, file systems, you have different technologies, you have cloud, you have edge, so all these tools and technologies work together and try to store the data. While we are able to get these data, we also need barriers prevent current intelligent IoT applications to adaptively learn from other IoT applications. So there is kind of a barrier between IoT devices. We are not still in a complete process at least, where two IoT applications have a proper communication possible between them. They don't talk to each other. So we need to overcome this kind of a barrier in order to have more intelligent systems in place. The evolution of IoT can be attributed to confluence in advances that took place over the past decade in computing, communication, and application design. And eventually, we had this situation or scenario. It was not that something that IoT was planned. IoT happened because the amount of devices that we were using eventually were to be integrated, and a concept that was framed was IoT. On the other side, data analytics is defined as a process which is used to examine big, small data sets with varying data properties to extract meaningful sites. These conclusions are usually in the form of trends, patterns, statistics that help business organizations in proactively engaging with data to implement efficient decision-making process. So eventually, this all boils down to decision-making process. Can we make use of technology in order to make a decision. I will share a very interesting anecdote. Mr. Sudhanshu Pandey used to be the finance commissioner, secretary finance, Jammu and Kashmir, and he said in 2008-2009 that decision making should be independent of the politics and bureaucracy. He said that, say for example, we have 100 crore rupees allocated for higher education. The question is, if in a union territory of Jammu and Kashmir, you're supposed to spend 100 crores, how will you spend it? Will you spend it in the subject of commerce, or will you spend it in the subject of science? If in science, whether in physics or chemistry, who makes these decisions? If we start campuses, say North Campus or South Campus, which courses are to be started? Do we need kind of a rationale for starting, stopping courses? And what kind of rationale it requires? It requires to predict what the student will require in future rather than reinvesting in already what we have. So from this point of view, data analytics, whether it's academics, it's business, it is a health sector, you will always find that the role data plays is trying to make independent of what the individuals make. The data should empower the decision making rather than the reverse. The leadership should rely on data, not individuals. Now, the topic which we have today, the convergence of machine learning and IoT. Fundamentally, these are two separate areas, and we're trying to make them as we try to have them converged into a single subject. Though they will continue to be two subjects which can integrate at some higher level. The convergence of machine learning and IoT paves the way for prospective advancements in efficiency, accuracy, productivity, and overall cost saving for resource constrained IoT devices. When machine learning algorithms and IoT work together, we can achieve improved performance for communication, computation, better controllability, and improvised decision making. IoT's potential has significantly improved with the convergence of machine learning and artificial intelligence. Advanced machine learning techniques have made it possible to mine the huge volumes of IoT sensory data to have better insights into a range of real world problems, as well as the ability to make critical operational decisions. So if we go through these 3 points, we understand there are certain keywords. The idea of abstract is that we need improvised decision making. We need make it possible that huge volumes of IoT data are used for better insight to understand the problems. Say, for example, if you look at an IoT device in isolation, so say a smartwatch, it keeps on giving its user a lot of information. So this is an IoT device which is interacting and giving the set of information to its user. But once the same set of information, the same information is used in machine learning, now we have to look at from two aspects. One is that we have a single user getting the kind of information he or she expects from a smartwatch. One second, please. Assalamu alaikum. Başta seçtiniz mi? Hello? Başta seçtiniz mi? Skopası? Asa chalo iki पूछिए मैंने. So I'm sorry. So we have two aspects, two subjects, two ideas. One is IoT, the other is machine learning. The IoT device, say a smartwatch, interacts with the user, provides him with his own insights. कि भाई मैं दिन में कितना चला, what was my pulse rate, how many calories have I burned. So this insight is from the device to the user. So he makes some kind of insight it ye kya kar raha hai, how is he spending his 24 hours, how long he's sleeping, and so on and so forth. Now imagine we have 1,000 or 10,000 smartwatch users in Delhi, or say 10,000 smartwatch users in Delhi. And this data is continuously fetched and stored on a cloud. And now machine learning algorithms are applied on this data set. What we get? We will get the sleeping pattern of Dahletites, how many calories they're burning, how much stress they are, how much water intake they have. So we are now going from an individual information to a kind of a community-based solution. The community-based solution is that we're trying to infer patterns and ideas from these smartwatch users, and then we try to improvise on things. Say, if, God forbid, somebody dies of a heart attack, we try to analyze his data. How many calories he was burning, how much of water intake he had, and try to alert a person who's vulnerable, who's using your smartwatch and understands your cloud detects that this person is on the same pattern as the one who had a severe heart attack and died. So you try to pass on the information back, which is not a simple information like how much of steps he has walked, but rather that how vulnerable he is getting to a specific situation. One of the interesting things which I lately read, that there was a football match going on between Arsenal and some other club, and there was this Apple watch smartwatch user who was alerted that the pulse is on a dangerous level. So the alert was not what he was doing. The alert came from the machine that you are vulnerable to certain situation. So you need better to take it off and get yourself ready for something else. Or in what we call in the near future, they could have called 911 and alerted that this person may have a certain situation, or God forbid, if some person has an heart attack, you can have a situation where your location, that person's location and information is sent to 911, and we may have a better condition to save him than if he would have not been connected with the device. Having said this, there's also a counter argument that you are also giving your private kind of an information to the system continuously. So that is a debatable issue, and some people, some societies, some scholars have shown concerns that this much of data sharing is not healthy for a society. Therefore, to solve real-world complex problems and to meet the computation and communication requirements successfully, IoT and machine learning must complement each other. In recent years, IoT data analytics has gained significant attention because of the following reasons. One, high volume of data generated from distributed IoT devices. According to the mobility report by Ericsson, the forecasting shows that there will be 18 billion connected IoT devices globally by 2022. So next year. So we have a population of 6 billion globally, or 7 billion. We are reaching to 18 billion devices. So the ratio nearly is 1:3, that you will have a ratio between a person and a smart device, this IoT device, by 3 times. And there are many IoT devices which exist all around us, but we do not realize it. But they are all around us. So the Ericsson, which is the leading mobile device company, says that we will have around 18 billion connected IoT devices by 2022. The number will keep on increasing over time due to wide adoption of IoT devices in a wide range of critical applications. Intelligent data analytics will play an important role to identify and predict the future states of any process or system by mining the huge amount of data efficiently and intelligently. So you look at IoT device from two perspectives. One, I'm a user, so I'm continuously getting the feedback from the device, the kind of feedback which I want. And the second thing is, that we are also analyzing the massive data. Say 1,000 smartwatch users in Kashmir, analyze their data, try to get the pattern, how much this society or the people from this union territory are walking, and compare it with Delhi people, and then compare the lifespans, the stress amounts, and how you can encourage one group of people and tell them that if you improvise your life by following things, how will it increase or make your life a bit better. So high variability of data types from heterogeneous data sources due to wide range of applications and requirements. A large variety of IoT devices exists, which includes mobile phones, PC, laptops, tablets, to short range and wide range of IoT devices. Due to the heterogeneity of the data, the feature, formats, attributes of the data are different. Also, based on different IoT application domains, the data sources also vary. For example, the IoT device used for medical applications will be different from a smart home IoT. However, the quality, processing, and storage of data have also become a challenging task because of its heterogeneity. So, when I started this session, I had to start with heterogeneity because this is a kind of a problem which we have not resolved. When in early 1990s, the computer science started gaining the commercial success, at least in Asia and Indian subcontinent down west. The idea was that we should only need to digitize the process. We did not at that time have standardization, which later on were made, certain standards were made for IEEE for certain applications and certain devices, but we did not have standardizations. We had numerous types of tools and technologies coming, which had different data types, format, features, and we reached a point where we need to integrate these heterogeneous data sources and have a single homogeneous source possible. One of the biggest and first attempts that were made in this process were of a data warehouse. Most of you must have heard about it. The data warehouse was an attempt in early 2000 where we wanted to integrate data from numerous sources, keep it in a single source, and try to analyze and use it according to our requirements. But the amount of volume, the volume of data that kept on coming, even we had then the big data in place, and the tools and technologies kept on increasing like anything. So at the end of the day, we still are facing this problem of massive data sets, massive amount of data being generated, different types of data being generated. There are PDFs, there are HTMLs, there are database files, there are simple files, text files. So all these data types and the amount of data makes it very difficult for us to integrate the system completely. Uncertainty is a very common in practical data analysis. It may arise in IoT data stream due to the failure of any IoT device or communication channel during data transfer. Gross errors and missing data are omnipresent in IoT data streams, which require advanced analytics to pre-process the data. When we study mobile technologies, we almost all of us go through the phases where we lose the network. So जब network ही नहीं है, so that continuous amount of data that was being sent and stored, we lose that channels. And so what happens? We will have at times compromised data. At times we will have data with error. So what happens is that we need pre-processing of the data. So while the best case scenario is that we always get clean, good data, which is possible for us to use, analyze, and store. But most of the times, the data which we receive requires pre-processing, needs to be stored. We have a concept called ETL, extract, transform, and load. We need to extract the data from different devices, transform and load it so that it follows a certain structure. In order to enhance the accuracy, during decision making, it's critical to ensure the proper assessment, propagation, and representation of uncertainties and develop models and solutions that deal with these factors. So, as we used to say to our students, that the first law of computer science is that if anything can go wrong, it will certainly go wrong. So, here the assumption is not everything is perfect. For a user, it may sound to be a perfect. For you, when you're using a smartwatch and you just click and see how many calories you have burned, this amount of data that goes to you is perfect. But when we are collecting this data from 10,000 smartwatch users, the type of data that is coming to us, whether it's clean, it requires some pre-processing, it has errors or it does not have errors, we need to develop models and solutions that can deal with these factors. So most of the times when we have IoT in place, we need cloud. Most of the IoT data analytics are performed in the cloud. Transferring data from IoT devices to the cloud is expensive, which may be challenging for time-critical applications, especially when the number of IoT devices is high. Now imagine if we're talking about that it's difficult for cloud. If we do not have a cloud and we have 10,000 smartwatch users, how will we collect this data at a central point? So please understand a scenario where the data transmission is not hourly, is not per minute, it is being transferred every second. Now, these number of devices are supposed to transfer data continuously without any barrier, and then we need to analyze this. For example, in a connected vehicle environment, a large pool of cars may be required to make decisions in real time or a near real time. Here it's important to balance the speed and accuracy of analysis when the number of vehicles increase. So, of course, in our country, we have now cars which are controlled by microcontrollers. The microcontrollers nowadays are very cheap, and many applications, many electronic devices are built around them. So, the interesting part is that if we look at a case study where we are trying to find which is the most, where is it that हमें सबसे ज़्यादा accidents होते हैं, which road is more prone or the most prone for accidents. So if we look at Srinagar, which may be a few hundreds of kilometers around, or you look at Mumbai where the number of roads and vehicles are ever increasing, how should we decide and how do we avert such accidents? So we have right now, say, satellite imagery, which keeps on grabbing the images. And then if we are able to analyze the locations where exactly we are having a possible accident, we can actually make a decision of speed and we can decide if we can avert a certain situation or not. So this is a classification of various analytical techniques for IoT. Here we will discuss different types of data analytics techniques. Below, one is analytical classes, descriptive analytics, predictive analytics, prescriptive analytics, and adaptive analytics. Do you have any questions till now, Junaid?
Yes, among the audience, do you have any question? You can unmute your mic or you can put it in the chat box.
Okay. So as of now, nobody is. Okay. So I should continue. Just one second. So these we will try to discuss different types of data analytic techniques, which we will be which will be of importance for our data mining for our IoT data. So, but before we proceed and discuss these ideas, I would like all of you, to have a look at how things work for us in a real-time environment. So, now what I'm going to do is try to set up our Google Cloud for an IoT device. You will, if you have not used it, it may sound difficult or it may sound different, but trust me, it's far too easy to have the setup being used in a standalone way, rather than if you try to manage your own hardware and try to build it up. So first, this is I will first go to the dashboard. This is our kind of a dashboard where different resources are visible, how many projects I have made, and so on and so forth. I can add people to this projects in the sense that if I create a project and Junaid wants to join in and start working on the same project that I'm working on, all I have to do is that I have to connect him to this project. And even if he does not have the resources, the cloud resources also, he can start working on my account. So if you look at the right side of it, there's a billing kind of a thing. So right now the billing is 0.00. So cloud for learning is extraordinarily cheap, but when you tend to implement it, then it starts getting costly. But if you understand as and when what you require, then it tends to get easier. So I'm going directly to IoT. So this is IoT core. So first, I would like to explain the difference between two words. One is IoT and the second one is IoT core. So you know what Internet of Things is, but IoT core is a fully managed service for securely connecting and managing IoT devices. So we are when somebody tells you it is an IoT core, it means that we are having a system in place, and the system manages IoT devices. So you will find Google Cloud platform, you will find AWS, which is considered to be the most successful platform for IoT devices, for managing these IoT devices. So when it's IoT core, it's a platform to manage and use IoT devices. So what are we going to do? We're going to change the project. So if you look at this point, इसमें marker हुआ करता था जुनैद. Why is it not visible? Junaid, you there?
Sir, I am Jahangir.
Huh? Sorry?
Jahangir, sir.
हाँ, sorry, Jahangir. Marker हुआ करता था इसमें, right?
Sir, you can maybe that may be available also in the PPT, I think.
No. Anyways, forget it. So I'm here. So first we have a project. So ideally, I'm going to start. I'm going to show I'm going to create a new project, and we're trying to set up the environment for IoT. So यहाँ पे हम लोगों को करना क्या है? We are going to allocate the resources, and then we are going to generate the public key, private key, and then try to have our devices connected to it. So connecting devices, of course, is something which takes a lot of time, but at least we can have an idea of all these things, how much time it takes, what all happens. The first thing I will do is create a new project. So I name this project as my project we can also have we can browse our organization. See, so now what we have, two things in place. If you're working for an organization and this project is being developed for an organization, say, then we can have it being developed for the organization and choose an organization and location. I'm using right now my personal Google Cloud account. The second account comes from the University of Kashmir, which is at the rate of uok.edu.in. So we try to learn here and implement there, kind of a thing. So yahan pe I'm not choosing any organization. Otherwise, if you look at from the industry point of view, you will be, this is a kind of a requirement. The second thing I do is I change the project now. मेरा default project जो था वो my project 2 है, so I change it to my project 3. Open. If you look at it right now, you will see that we are trying to have a new environment being set up. And this environment requires enabling certain register and manage IoT thing devices that connect to Google Cloud Platform. We will also use SaaS and category it belongs to big data. Before we go in there, I would like you to go through this pricing kind of a thing. So there's this free kind of a thing which starts at zero kind of a thing. But then if you look at tier 1 and then tier 2 and tier 3, so this is a kind of resources based on आपके पास कितना data आने वाला है, आपके पास कितने users आने वाले हैं, and how much of data you require for this to come forward. So there are two aspects here. One aspect is that I can work directly on the cloud. Here, there is a console on the cloud. The second one is that we have to install something for the cloud. So this. So this is a software development kit, which is for Google Cloud. But then you need to install tools for it. So this may be a bit cumbersome. So यहाँ पे ये कहता भी है run gcloud -h. So this will give you kind of features you have. So this may require some amount of effort अगर आप ये खुद करोगे. But the other way is that if you have worked on Linux or Fedora or Mac machines, then it is better that you directly work on their console, which comes here, Activate Cloud Shell. यहाँ पे, it's on the extreme right top, Activate Cloud Shell. So what happens now, all those all of us who work on Mac or Fedora or Red Hat Linux or any flavor of Linux or Unix, they will find this Google Cloud Shell machine the same as they used to find their own shell. Is the shell visible in front of you? Is the shell visible? So if you are using Cloud Shell, which comes with Cloud SDK and Node.js already installed, it comes pre-installed with every requirement of softwares and other things. So you don't have to do anything. So compare these two. You can also, just one second. So we are having two equivalent environments. One, you install it on your desktop, whether it's Windows, it's Linux, or it's Mac, or you decide not to install anything on your machine. You're directly working on you're directly working on the cloud. So this is the first thing. I'm going to stop this thing for the time being. The second thing I'm going to do is I'm going to enable it. So what am I enabling is Google Cloud IoT API. It will take 1 minute. Okay. I hope some of you have gone through the what we call telemetry transport. Has anybody heard of telemetry transport algorithms? Has anybody heard of telemetry transport or MQTT?
Yes, sir. MQTT. Message telemetry transport.
Okay, Jahangir has done it, huh?
Yes, yes. Where we have sender and receiver, and we have a broker in between.
Yes. Okay. Great. So we are going to make use of it. When we're going to use the IoT devices, we will require this, and it was developed way back in 1999 or 2000, if I remember it right. So it's of very much of essence here. So, anyways, we'll be using it. So the first thing is that we need to create a registry. यहाँ पे. So the first step, enable it. You can create your own project. Then the second thing is that you enable your IoT. The third thing is you create a registry. When you are doing this, you have to understand that the GUI that has been developed by Google or Amazon is very easy, but it requires a couple of steps to understand it. And if you do your own hands on it, it will tend to be very easy. Anyway, the first thing I will do is I need to create a registry. So registry ID, your choice is whatever you want to keep. I will say my registry. Google ने has kept it in a kind of like default जैसा रखा. अगर आप सीख रहे हैं तो you will find my project, my directory. So registry ID is my registry, and region is, if you're not, of course we will prefer Asia East 1 as a region. So there will be the concept of pricing which will be coming up here. Now we will go to the cloud pub and subtopics. So we need to know what pub and sub is in Google Cloud. So this is a publisher subscriber, allows services to communicate with latencies on the order of hundreds of milliseconds. So as of now, we will try getting into this detail also, but first we will try to set up here. We'll go ahead and okay. So we are going to use MQTT, the protocol, not HTTP. So you will uncheck this. The second thing is now, which is very important, is that we need a certificate. And this is where we need to create the public key, private key thing. So kind of a very important kind of a thing. So यहाँ पे पहले हम लोग क्या कर रहे हैं कि that there is you have to choose the protocol. And once you have chosen the protocol, and the second thing you will do is it is disabled. अभी इसके बारे में we don't require it, but once you get into the professional kind of a thing, then you may require it. And CA certificates जो है अभी ये optional दिखा रहा है, but we may require it. So in case we create this and we realize that we have not completely done what was expected from us, जैसे हमने किया, we can delete this registry at any point. So just delete it. But what you have to do is you have to write the name as it was. That is my. So the easier aspect is create a registry, give your name. It's not necessary that you will keep iRegistry, but it's kind of an easy. Second thing is that you will go with Asia East 1. अब ये क्या है कि which is the closest? The region has to be the closest region for you. The closest region for you in this case is Asia East 1. At times you will find कि ये ज़्यादा busy है. So then it will tell you that I am unable to use it because of some reasons. So what we will do, we will then choose Europe first. If it does not work for us, then we'll go for the US Central. So the preferred one is that you will choose Asia East 1. So then we have additional topics. We don't require them now. Then we will go to the show advanced topics. So the first thing it asks for us is now select, we have to select MQTT, यहाँ पे protocols में, which is important. And we have to now create a topic. और ये create a topic यहाँ पे. I hope this is visible for you. When you go to device state topic, optional, यहाँ पे on the left side there is a topic. So you will come to know why we require. यही topic फिर आपके जो messages exchange होते हैं, it's required, it's used there. यहाँ पे हम लोग लिखेंगे my your call, मगर kind of a Google kind of a thing is that if you're doing it for the first time, you will use something like this and create a topic. Okay. The new topic has been created. MQTT has been done. अभी आप CA जो certificates है, we will not use them for the time being, and we'll directly create the registry. So I hope the kind of a thing is that you are in a position to create a registry जहाँ पे सारा कुछ information use किया जाएगा eventually. So you look at it from here. यहाँ पे if you look at it that there is a region is Asia East 1, protocol is MQTT, and rest we have not done much. एक चीज missing है इसमें कि we could have kept topic name here इसमें, but we have not done that as of now. Now the second part is, if you look at devices now, there are no devices. We need to add devices to our registry, which we'll do at a later part. The second thing, what we will do is this. We will start the terminal. Just 1 second, please. Just 1 second. Okay. Now the second part is that okay. So we could have edit certain things here. Now, what I will do is I will open this terminal and I will start working with keys. So has anyone ever generated a public key, private key, or has any one of you worked on it? Jangir, you have worked on it? Anybody
Not
has worked on it? So anyways, if you have not, what we will do is that uh, I will just use it's like a Linux environment or a Mac environment. If you have worked on Linux or Mac, then this is a kind of environment for you. So I'm working जो traditional Linux model था ये वही है वही kernel है. So is this visible, guys? Is the terminal visible? Is terminal visible?
yes, sir. It's visible. Yeah, right now, web browser is visible, sir.
Okay. Okay. This I hope it's visible now.
Yes, it is visible, sir.
Yeah. So we are using the same root sh shell, and we have this terminal in with us. So we're going to use combination of things which will help you in creating these keys, then downloading them. I will show you what this Google CA root certificate is. So first, we're ahead. The Google allows you to close this and open this terminal anytime. So if you're using the inbuilt terminal, you do not need to install anything on your machine. So the entire integrated environment is online. The only thing you need is your internet, nothing else. So I will just try to generate a key. So this is RSA, we know. You don't need to remember it, huh? Okay, I have committed एक गलती कर दी है. हाँ. 1 second. 1 second. Huh? Just 1 second. Huh? 1 second. 1 second. Committing some. Just 1 second, 1 second, 1 second, 1 second. Okay, sorry, I have already a key in place. So I think I will not require it. Let me handle it first. So first I will go back here. Just 1 second. Okay, why I'm not able to create a root certificate.pem? It is because I have been already, there's already one issued in my favor. So I cannot recreate a new one. So I will just share my existing one with you. Just 1 second. I'll just. Just 1 second. So I'm getting it from here. Okay, sorry for the deference. So I already have this certificate issued, so I'm not generating the new one, and this is it. This is the roots.pem. It will show in the folder something like this. If the Google Images is able to open it, open with, just 1 second, I will just show. I don't think so. No. So I would have ideally tried to show you the structure. I will show you, I will get it from, just 1 second, guys, please. Bear with me. It won't open on the Windows environment, so I don't think so I will be able to show. But anyways, you are required to download this roots.pem because eventually when we implement this thing, we will have to upload it back to a specific point, which I will be showing you in the due course of time. For the time being, as and when we will require it, we will go to the registry pages again here, and we will add devices. Now, this is where which gets very interesting, that how do we create these devices. As of now, we are using a virtual device and we will not be using the physical device. But at some phase later, we can be in a position to add a physical device. The process will remain more or less the same, whether we're creating a physical device or a virtual device. But at the end of the day, this is just, we have to follow the same kind of rules and logic. So anyways, we will create a device. First, we will have a device ID. So device ID, I will keep my device. Okay. Now we will need to click this. So यहाँ पे we need to add certain things. One is that we need to copy the contents of RSS certificate. For that, we need to use the Node.js on which we will work. Does anybody know what Node.js is? Anybody knows what Node.js is? So we need to have the keys in place. One is which type of key, जो यहाँ पे हमारे पास key formats हैं. So has anybody used public key or private key, Jahangir? Or like, do I need to speak about them?
No, sir, you need to just mention it that this is key, but I don't think we should explain it over again.
Okay. So as Jahangir said, that we will assume that you have worked with the keys. So we will go ahead with the process of creating this thing. So यहाँ पे जो भी आपको मर्जी है, first and foremost, it's not a kind of a required kind of a thing that you will always use these kinds of names. These are just kind of simple one things. हाँ, यहाँ पे दो चीजें हमारे पास are very important. One is that you use this public key format 509. So there are different kinds of it, and as Jahangir told me that we assume that you know it. And अगर आप इसमें click करेंगे, तो you will see that यहाँ पे ये कहता है हमें कि that you have whenever you copy and paste it, then you need to do it along with the begin public key and end public key. So we need to go back to the console. I will take a web preview here. It's taking time. Okay. Okay, so I will use existing keys which are available with me. Right now, I'm in this present working directory. Unless I can do one thing for the time being. If you're able to see here, यहाँ पे, So you will see here there's an RSA cert PM. Is this visible? This is visible for you? Is this visible? Try to enlarge it. Is this kind of a visible RSA cert.pem?
PEM. Yes,
Yeah.
yes.
So if I VI it, this is the key. And let me go back here and terminate this thing. If you look at this and click here, he tells you that it has to start with the public key, begin public key, and this. So if you look at a shell, it says exactly the same thing, that it is the public key and begins the certificate, and you actually need to copy this entire thing up to this end certificate thing. So this is what needs to be pasted out here. I will do it again for you. So when you do it, you need to activate the cloud shell. This. So if you can also just, if you're comfortable with your Linux kind of a thing, so then it's kind of easy for you. So I will take more of a graphical route, and it will help you in an easier sense. Start. Google is having a problem. Okay. Anyways, I will use VI editor, the traditional one. And I will copy it from here. Just 1 second. Just 1 second. This one. I hope this is now visible. Okay. Control C, minimize it, and paste it. It's tricky bit at times because you have to take it, copy and paste it, and there's a different kind of an environment here. So I've now copied and pasted it, and all you have to do is, I'm not keeping any expiry date here, so I create it. Okay, but remember, यहाँ पे, if you do it again, because it was getting a bit confused, if you at sometimes decide to delete this my device. So what is this my device? My device as of now is a virtual device which has a proper public key, private key associated with it. So if at any time you want to delete it, all you have to do is, okay, and you can create different types of devices, multiple types of devices. But as of now, what we are doing, we're creating one device. मैंने इसका my device नाम रखा. Then we go here directly. यहाँ पे हम लोग ये वाला format use करेंगे and paste it. We are not using, you can have a concept also where you will decide when it will expire and create. Okay. यहाँ पे, since we don't have that much of time where I can explain what these things are, but the interesting part is that you have just added a device. This is your device, and you can use this documentation also. यहाँ पे core IoT documentation if you want to address certain things. यहाँ पे this is your IoT Google Cloud IoT core documentation for beginners. It will help you as and when you require it. Now what we have is, if we look at it, we have a registry, single registry. We are using by the name of, we're using Asia East, we're using MQTT for it. The second thing is, in this registry, I have created one device. So communication is allowed. I can create another device. So we can have, say, my device 2. So it's not that you're restricted to a single device. You can create multiple number of devices. All you have to remember is that as of now, you will choose the key format, paste the key here. That's it. Nothing else. So Google does not complicate things for you. All you have to do is that use an existing Google platform, use an existing resources. So two things stand done. One, a registry created. The second thing, we have created a device. The communication is allowed. We have given it a key. Jangir, can we take a 5 minutes break here?
Yes, sir. Yes, you can take this.
So this is 3:38 around. At what time should I resume?
30, sir. Maybe you can take 10 minutes.
Okay, 3:45, 3:47, huh?
Yes. Yes.
Okay, thank you. Was ist Sessions? Just otururken al bu şey tinat kamerası bunu stabil bu şey numara sessions mı? Mega sessions mı? Valiye başka. Okay. And then the subscription, sorry, and then next one is MS session. Can you wait for some time? I'm in the online session. Okay. So projects में यहाँ पे फिर से this is a command. I will prefer it copying and pasting it, kind of an easy for me. Otherwise this will एक छोटी सी गलती. So I assume that I must have committed mistake, most likely. So if it doesn't go well, then I will just copy and paste it. This command creates the subscriptions for detailed information. So what it does is that it creates a subscriptions for me, and because of those subscriptions, जहाँ पे ये messages save हो जाएंगी. So I will just copy it from my device. Just 1 second, please bear with me. Just 1 second, please. Just 1 second. This will save my time and yours also. Minimize it and delete this, paste it. Project ID जो है, so this is a kind of a copy paste kind of a thing. So my project ID is this. Copy it and we can now execute this command. So जहाँ पे project ID है, all I have to do is replace it with my project ID. This is a bit different with most of the students of computer science. Finding it different in the sense that most of us have not used it while in the academic lifetime. So I have to execute this. Done. So this works for us, and what happens is that we create subscriptions for our system. Once the subscriptions are created, then we have to run again a command where these statements can be saved. So this is where your final thing works. So your IoT devices are set up for receiving the information and analyzing, only for receiving the data. So once the data is received, then you can start analyzing it. So the point here is that what Google does for you is it enables you to create this environment from a scratch, to just conclude and make it a bit easy for you in case you would like to try it. Is that how do we start it is just by choosing the project, which you can name on your name anything, say create. Once the project is created, the second thing you will do is create a registry. Go to the specific project, enable the Cloud IoT API. Once this is done, okay, I will use an existing one. Okay, so यहाँ पे API enabled है. Then what's the next thing we do? We start working on this. Try this API. So this gives you a kind of a documentation in case you get stuck somewhere. The commands, how do you create, delete, overview, सब कुछ. Cloud IoT API. For in case you wanted an interface like this. So in case you still get, you still have confusions, all you have to do is go here. It's not working. Even Google has issues on times. Otherwise, this is your pure environment. So IoT. IoT core. This is your registry. You can create a new registry, or you can go to a specific registry, one you have created. If you want to create a new registry, you can do it here. Once you are in the registry, create a device. This device is the one which we have already created. Now, what is this device? This is that device which can turn out to be your smartwatch. Once you enable, once you give them the keys, the public key and the private key, they will hook up together, and the information which I was talking about at the start will start coming to the publisher and subscription, where the information will be continuously stored. Once this information is continuously stored here, then we will go into this part. Then we go into the Vertex AI or AI platform. This is the new Google kind of a thing. It is based on deep learning. Once your entire data has come, this is what you will be using for the machine learning and prediction thing. So यहाँ पे we are having the three things: preparing your data, train your model, get predictions. Again, in case you have not used it, Google enables you to use the tutorials and you can start using it. But from an IoT point of view, the first important aspect is this. It may look and sound complicated, but the first important thing which you need to work on is getting your devices connected with your cloud. So for that, you need IoT core. In the IoT core, you need to create registries. In the registry, you need to create a device. In the device, you are supposed to have the public key, private key information. Once that is done, the devices are up. You will have my device where you have kept the communication allowed. Once this is done, then you can start getting the data from these devices. The device data is done, then you will go to the next part, and that is you have two options: AI platform or Vertex AI. The Vertex AI is a new inclusion. It empowers the machine learning developers, data scientists, data engineers to take projects from ideation to deployment, quick and cost effective. ये interactive है. Try an interactive tutorial to learn how to train, evaluate, and deploy a Vertex AI Auto ML or custom trained. It works on your Keras and TensorFlow, and it has 3 steps. You will find here many more regions. The closest to the India will be Taiwan or I guess Hong Kong. और नहीं, इसमें मुंबई भी है. So this is your Asia South one. So if you're working from India, this is the region you will use. Then this requires us to create a data set. Data set आपके पास है अब, the one which you have brought it from the IoT. Then you will train a model, and then you will create a batch prediction. So these 3 steps is where we conclude at some phase once the IoT data is available with us. Having said this, we are basically connecting two individual tools. They are two separate tools which are working together. First, the IoT, and then the data that works on it. This is one of the most used tools and takes a lot of time to get used to, especially the IoT one, because you are in IoT, you're creating you are connecting to devices, but the machine learning part of Google is much easier as compared to the IoT part, because the data set is already ready. So prepare your training set, and then you start choose the algorithms and then get the predictions. But the IoT thing is that you need to connect the devices, and for that you need public key, private key. I have not extensively done it, but I just wanted you to get a feel of it, that it's not that complicated as it sounds. I hope you just got an idea of it. I know it's not possible for us to have a justice on IoT from a technical aspect within a 30 or 40 minutes, but just an overview that what is happening. यहाँ पे अगर आप देखेंगे the concept of data sets, if you have worked on machine learning, the life has gone beyond the traditional thing. We can now just, if I have to enable this, for this, the billing will be done. So it's kind of, we use the other platform for this. But if you try it, you're a new user, you can use this and start using it. At the end of the day, you will be able to implement the machine learning models on the IoT data here in this platform. Or you have the other one, which is more traditional, not the Vertex AI, but the old version, which is AI platform. There's a kind of a difference between these two. That this is complete. The older one, the new one, is completely deep learning and TensorFlow, Keras. But this actually has all shades of new and old data. So यहाँ पे आप notebooks use कर सकते हैं. I think you have, some of you must have used Google Colab, and if you have not used Google Colab, you can just start using it on any given day, and other notebook APIs also. All you have to do is you go to google.com and press Colab. And this is your Google Colab. Complete Python-based environment for machine learning. Just 1 second. This is your Google Colab. And one of the, like, it's pre-integrated, pre-installed version of Python, and it works very well for us. Whether it's, they have given a good number of instances where you can start using it, or you can start working on your own work, जिस पे आप खुद काम करेंगे. So for that, this. So this is our, you can create a new notebook and start typing, working on the Python integrated environment. You don't have to install it on your machine. So this gives you a Colab perspective. If you have worked on it, it directly works with your Python and TensorFlow. So just align, all you have to do, don't need anything else. So Google, what I'm trying to infer is that Google gives you a complete environment, from IoT to machine learning to writing your customized. यहाँ पे हमेशा customized नहीं होते हैं algorithms. They can all be just choose and execute. So you have both options to execute your data on. And once you're done, you can start using this thing directly. It's connected. You have some 8 GB of RAM available on your mouse click. I will just go back to the presentation part. So I think that I'm just 1 second. short of time. So we have a descriptive analytics for IoT. So once the data is gathered, first the registry is made, then the devices are connected using private key, public key algorithms. Then what do? We get the data, and once we have got the data, IoT systems can gather data from few to thousands of smart devices. So I have just shown you a concept of a device, how you add a device to your environment. Based on a historical data, it's always possible to generate detailed insight into past events, and you perform the second one is the predictive analytics, relies on historical data and utilize advanced statistical or machine learning techniques. It predicts what will happen in the future. So this is the most used kind of a thing we have right now. The third one is the prescriptive analytics of IoT. It is suitable for industrial IoT setup where business intelligence-based decisions are made by using the capabilities of cloud, edge computing, big data analytics, and machine learning. From the research perspective, we are still work more on the predictive analytics of IoT. So then next one is adaptive analytics for IoT. During actual implementation, the outcome obtained from the predictive analytics needs to adjust with the real-time data. So we are aware of the training set, test set, and then accuracy and prediction, which models, machine learning models are used. But once they are in place, adaptive analytics are used to adjust or optimize the process outcome based on the recent history of data and by looking at their correlation. This type of analysis helps to improve model performance and reduce errors. Okay, the classification of IoT data analytics based on technological infrastructure. The first one, which we spoke of, and which we are more interested in, is the cloud computing. In the cloud computing, remote located computing facilities are utilized using internet to store, gather, manage, and process the data. So in this case, the IoT data only. In the past decades, especially more recently, cloud computing has gained much attention because of the new infrastructure and processing services like software services, platform as services, infrastructure as services. The second one is edge computing. Simply refers to analytical capability near the edge of the network of the IoT device. The importance of edge computing can be better understood by realizing the challenges and limitations of cloud computing. So cloud computing is a centralized way of data processing and may increase the overhead of processing the massive data. Sending the raw IO data streams to the cloud would increase the cost and will require high communication bandwidth and power. Instead, edge computing enables the computing bandwidth of the local networks of the source of data. Therefore, it solves the bandwidth problem. Say, for example, you are in National Institute of Technology or any university, you can have an edge computing which will perform this process of analysis locally and not be spending the lot of money on the bandwidth and cloud computing. So this is kind of an overview. If this diagram is available, the components, convergence of IoT architecture and data analytics and illustration. So this and a generalized system model for collaborative edge cloud processing in heterogeneous IoT networks. So this is your IoT gateway. And now you have to see the different types of devices which are connecting with this. So edge processing and cloud processing, this is kind of a model which is considered to be the most successful in terms of performance, is that you have an IoT gateway in which most of the data processing, if required, is done. Then the core network and internet cloud, and eventually the data can be saved on the cloud. The more suitable IoT architecture is one that is on the left side, the cloud server, descriptive analytics, predictive analytics, prescriptive analytics, supports by high memory and computation power. So whenever you see the cloud server, more of it, you should imagine it as a Google Cloud or AWS Cloud or a Microsoft one. So it's a massive infrastructure which comes without a local installations. Edge or fog node, a lightweight online algorithm supported by low memory and computation powers. So IoT end devices, wristband, temperature humidity sensors, smart homes, smart medical devices. So they all hook up to these edge or fog nodes, and from there it goes to the IoT architecture or the cloud server. So this is an end-to-end diagram. So when we were working, sorry. What I was trying, we were working directly on the highest level. We were trying that the cloud server directly communicates with the wristband, and we were ignoring the lightweight online, this edge or fog nodes. While this is a perfect situation, but it requires a lot of infrastructure in terms of bandwidth and internet resources, wherein you are enabling every device, IoT end device, to communicate directly with the cloud server. It comes at a price. The better kind of architecture is that these devices connect with the edge or fog nodes, and from there we hook up with the main cloud. So applications of IoT data analytics is IoT data analytics for smart vehicles. Yeah, IoT has enormous potential in the connected vehicle environment, especially for efficient and accurate decision making using advanced data analytics within an Internet of Vehicles (IoV) paradigm. A large number of broadcasting messages are frequently generated with high granularity and volume. Therefore, one of the biggest challenges is storing and intelligent management of huge amount of data. So we come back to the first point, that IoT generates massive amount of data. Your credibility lies primarily in storing and managing this massive amount of data. Another key issue is related to ensuring the security of data, as any cyber related anomalies or cyber intrusion attempts may jeopardize the system and may cause fatalities. Hence, it's important to look for intelligent solutions that can deal with such cyber related incidents. Okay, this is a three-tier architecture of IoT-based system for several applications in a connected system. I will just differentiate, or the main explanation is based on the three lines which are written on the extreme left: the application layer, network layer, and then there is a perception layer. So if you look at the devices which are mentioned on the extreme bottom, is your smart cell phones, bus cards, terminal boxes, smart sensors, fare boxes, video cameras, signal devices, smart lamps on roads, staff cards, mobile devices, cameras, videos. So these are all your IoT devices. So we have tried to differentiate them, that once these devices are identified, then you need a technology by which the data from these devices are transported. For this, a network layer is in place. So the communication protocols will remain more or less the same, which you have heard of, including TCP/IP, UDP, extra. And once this is, then we will go to the integrated, the application layer, where we want certain things in place. Online monitoring and control of fleets, dynamic vehicle scheduling. It depends upon the type of application which you're using. And the application layer will not be generic in this. It's not that we will always use the same set of applications. We may use the varying set of application based on the type of IoT devices and the applications we require. So this is a three-tier architecture. The first layer, the perception layer. The second is network, and the third is the application layer, or the IoT is used by advanced analytics. So the top one uses the advanced analytics. The second one, or the middle one, is the framework is responsible for transferring the source data to the application layer, or the final layer. The first one, or the perception layer, data are gathered from various IoT sensors and devices. For example, a passenger's smart cell phone can provide a location information of the passenger, where a smart travel card may contain information related to passengers' identification and financial transactions, and so on and so forth. Likewise, we have examples for smartwatches, cameras, so on and so forth. A framework for machine learning and knowledge discovery for IoT, learning from human-computer interaction. Theory one is that how a human can interact with websites can teach how machines should interact with other machines. So a framework in which we can learn from a human and computer interaction and develop our framework based on those. The most relevant property of a website is its presentation can be easily understood. Users can semantically navigate the perceptions. There are two characteristics of knowledge sharing that can be drawn from a human computer interaction. Thus, we propose the following theorem. Theorem 1, naming an entity, and theorem 2, information must be arranged semantically in a way that it allows human to derive meaning by following its structure. So I will now try to skip and go to this part because I think we are short of time. Smart objects share their services, enabling them to learn the breakdown of rules to a set of tasks and events. So data, this is the gateway, and this is NLP. I guess you have already heard, most of us have heard about natural language processing, how and we know the challenges NLP gives us. We may be belonging to the same country, from same state, same community, but we have different pronunciations, accents. So it's not kind of an easy to process the natural language. So anyways, this is more of a how smart objects share their services, enabling them to learn the breakdown of rules to a set of tasks and events. So just one second. Go to the previous one. The future opportunities is improved cybersecurity. As of now, it is one of the major concern for the industry as well as individuals that we have a proper security of our data. Application layer should not be compromised. So for improvised decision making, machine learning algorithms heavily rely on IoT data generated and transmitted from IoT devices. Within an IoT framework, different IoT layers, perception layer, transport layer, application layer are vulnerable to cyber attacks. For example, malicious code, injected node tampering, impersonation, denial of service attack. So we need a better security mechanism. Machine learning at the edges. So we already spoke about that having everything on cloud first and then analyzing it requires a lot of bandwidth, which may come at too heavy of a price. So we should have local edge installations which will help us to achieve our goal without spending too much of money. IoT technologies have enabled the platforms to communicate amongst a large number of connected pairs. When critical applications and end users require a big number of interconnections, scalability becomes an issue which needs to be addressed. For example, a large volume of data needs to be distributed to several end devices where the devices simultaneously solve computing challenges. So this scalability is still an issue. Hyperconvergence, storage facilities are shared among us a large number of distributed nodes, and their combined performance helps to recover from the resource sharing problems. So these are just the references. I will just, before concluding, I will request if there are any questions you'd like to know about something, or how do you find this kind of a platform that Google allows? I think most of us are new to this kind of environment, but if I'm of any help and I can be of any, I can answer you any questions, please feel free to ask them. Jahangir?
Yes, yes, yes. Yeah. Am I audible, sir?
Yeah, completely audible.
Okay. So you have completed. I was just on a call. I forgot to, what was the last?
No, okay. I was just saying that it's just an introduction. You know, the technology requires time. So
Yes,
if
definitely.
in future we can have 1 week on IoT implementation, so it will give the participants, but you cannot do it online. It needs to be a physical
Yeah,
FDP,
that is
because I think on the online platform it gets kind of a tricky and difficult. But if we ever get a time, I will really see, because
It's
you
it's a
you
sort
do
of
a lot of
monologue
such
where
workshops.
it's a it looks like that you are just in a one-way direction.
Yes,
Nothing from the
you don't know because how much the person knows, because there's
yeah.
many terms and terminologies which you use, but you're not sure whether the audience knows it or not.
Sure, sir. So still,
Yes. So anybody has any kind of questions? Any questions? I believe this was a bit of a complex topic where we were trying to integrate many things, and we just had a couple of hours. But maybe next time we will implement only IoT on real life devices, and it may be actually more of a pleasure for the audience. But if the session is physical,
surely inshallah, hoping in coming days we will have some sessions, in physical in a physical mode at the time.
yeah,
Yeah. So, thank you so much. Thank you so much, sir, for
it's
having
always
this
a pleasure.
full and in-depth analytics on this topic. Surely, thank you so much, sir.
Okay, sir. It's always pleasure being in your company. Thank you very much, Jahangir.
Thank you so much, sir.
Okay.
I think
Thank
this is.
you very much, sir. It was a
Thank you, sir. So this summarizes the day. Now we are left with one last tomorrow. So hopefully we will join in the morning for the first session. So thank you so much all participants for